Hello and good evening to our audience in Asia and Australia. Good afternoon to our audience in Africa and Europe. And good morning, everyone in the Americas. It's really early morning. So here's wishing everyone good health and happiness. And welcome to this on demand conversation on health. Now, during our previous webinar on 27th of August, which was attended by a large number of audience from across the world, we asked audience about which health topic they would like to hear our speakers on. And the top two topics are exactly what we requested our speakers to talk to us today. Yes, about our gut or digestive health and memory. Now, it's so humbling to have so many of you come back to this third conversation in past 6 months. We are glad that you are finding this conversation on health meaningful, and hopefully, all of you have started adopting to plant based whole food diets or PBWF diet. Now, in a very recent issue of Journal of Gastroenterology, there was a very interesting scientific paper published which analyzed data of 73,000 individuals in 33 countries across 6 continents. And here is what they concluded, and I quote: 40% of people worldwide have functional gastrointestinal disorders. Yes, you heard it right. 40%. That means around 1 in 2 people in the world suffer from gastrointestinal disorders. What we eat affects our whole body, but the digestive system is the first point of contact and thus reacts very strongly to the diet we eat. Research clearly points that plant based whole foods are very beneficial for digestive health, and at the same time, research consistently shows that animal based diets are detrimental. And hey, let's talk of aging. Aging is a natural phenomenon, we cannot stop it, but at least not until now. But a decline in brain health is not an inevitable part of aging. How we eat and live can help us protect our memory and stay sharp into old age. Plant based whole foods, again, are beneficial to the brain and can help us stay mentally active no matter at what life stage we are. So, today, as you can see on your screen, we have two very interesting speakers who have made it their life's goal to reduce the chronic disease burden on the societies and the nations. We will introduce them to you shortly. Now, this webinar is brought to you by Wellness We Care Thailand. At Wellness We Care, we are a team of doctors and healthcare professionals who work to educate healthcare professionals as well as common people on prevention and reversal of chronic disease, mainly through plant based whole food diets and lifestyle modification. Wellness We Care is an initiative of Mega Life Sciences, an organization whose goal is to help you stay healthy as long as you live. Now, this webinar is to empower you to take charge of your own health with simple, effective, and scientifically proven diet and lifestyle changes. And we are excited and happy to have partnered with Plantrician Project USA, with whom we share a common passion and belief. Now, my name is Sachin, and I'm your host for this webinar along with my friend Tom, who is in USA right now, and it's pretty early morning there. So thanks, Tom. And before we begin, just a few housekeeping announcement. As I see, a lot of you are putting your messages in the chat window. Uh, so my request is, if you have a question, please put the question in the Q&A window. So now, if you see on your screens, there is a chat window and there's a Q&A window. So we will be monitoring the Q&A windows. What we will do is that each speaker's presentation would be followed by a Q&A session from you, the audience, for about 10 minutes. And to ask the questions, please use the Q&A window on your screen. Type your questions there, and myself and Tom will compile your questions and put them to the speakers on your behalf. To make this session interactive, we will also put in a short poll question for every one of you to answer. Please make your choices when we put up the poll. Now, without taking much more time, let us start with our first speaker, Dr. Scott Stahl, co-founder and chairman of Plantrician USA. Scott received his medical degree from University of Colorado. He is a board certified physician. An interesting fact about Scott is that he was a member of American Olympic team in 1994, and he's still associated with the sports team actively, but this time as a team physician. So Scott co-founded Plantrician project in USA, the goal being to educate, equip, and empower physicians healthcare providers, and other health influencers with knowledge about the indisputable benefits of plant-based whole food nutrition. Another interesting fact about Scott is that he has been featured on numerous TV shows and popular documentaries like Eating You Alive and Game Changers. I'm sure many of you would have seen that on Netflix. He's highly sought after international speaker. So, ladies and gentlemen, here is Dr. Scott Stahl.
Thank you so much, Sachin, and it is such an honor to be a part of this team, and I am so thankful for the amazing work of this team to host these webinars. And it's also a special honor to have all of you join us on this webinar series. We are just delighted that you've taken time out of your busy days, whether it's morning, afternoon, or evening, wherever you are in the world, to join us for these important topics. And it's our hope that you will be empowered with this knowledge, not only to transform your own life, but to transform the lives around you, because that's how we will see a global transformation of diet that not only benefits human health, but it benefits the environment and animal welfare and every other aspect of life. So we're delighted. Thank you for joining us. I'll start sharing my screen. And today we have a very important topic that I just have 20 or 25 minutes to cover. And there have been tens of thousands of articles published on the microbiome and human health and gut health. And so I wanted to use this kind of as an introduction to the microbiome because it's so important, not only in irritable bowel disease and IBS, and heart disease and type 2 diabetes, but it's impacted by our diet. And so I wanted to give you 20 or 30, 25 minutes of a good deep dive on the microbiome to give you a foundation on which we can build in the future as we talk more about other diseases. So there are 100 billion stars in the Milky Way galaxy, and on a beautiful starry night, we can look up if we don't have light pollution and see a magnificent sky with stars dotting the skyline. But in our bodies, we have between 50 and 100 trillion bacteria that colonize our skin, our mouths, our stomach, our gut lining. We are actually more bacteria than we are human. And when we look at the amount of DNA in our bodies, there's maybe 10 times more DNA from bacteria than there is human DNA. So we are really a community kind of organism. We have our own human DNA and we have communities of bacteria that also work in a synergistic way with us to optimize our health. And it's not just us, but this microbiome is everywhere. It begins in the soil, and we see that it colonizes roots of plants and leaves of plants. It's on the skin and in the guts of animals and fish all throughout nature. And so it's this very dynamic, interconnected relationship with bacteria that actually allows life to grow and to breathe and to move forward. Our microbiome, when we look at the human microbiome, specifically the gut, contains about 50 trillion bacteria. And if we took all of that bacteria and combined it, it would weigh about 3 to 6 pounds, one of the larger organs in our body. But it's not just comprised of bacteria. It also is composed of viruses, fungi, archaea, which are methobacteria, and protozoa. So it's this dynamic community of organisms that colonize our gut. And the types of these bacteria, including even the archaea, which we know very little about, have an impact on our health. Now we know the microbiome has a significant influence in our health. It's estimated that the microbiome influences our immune system, and that 75% of the activity and health of our immune system from T regulatory cells and beyond is related to the health of our microbiome. We know that, as Dr. Sant is going to talk about later, that the microbiome is involved in aging, directly impacts inflammation, cognition, and our mood. It influences blood vessel health through angiogenesis. We'll talk about that a little bit later. It also impacts the formation of cancers, including colon and colorectal cancers. The bacteria have direct feedback to our hypothalamus and can influence satiety and hunger signals, actually stimulating cravings for sugars that go beyond our own ability to desire foods. The types of bacteria influence the amount of calories that are actually absorbed in the gut. And finally, as we'll talk about a little bit later, the types of bacteria also influence cholesterol and estrogen management within the body. But what's specifically interesting about the microbiome is that it is influenced and impacted by the environment. And our first influence, the first place that we receive this kind of commensal bacteria inoculation is at birth. And the studies have shown that babies born vaginally have a very different microbiome than babies that are born by C-section. In fact, when they look at the microbiomes of babies born by C-section, they have very high pathogenic bacteria like Klebsiella and Enterococcus that colonize their guts. And they believe that this is for a number of reasons. One, obviously, as the baby is born vaginally, it receives and swallows the vaginal fluid, and that begins the first colonization of the gut. However, for babies born at C-section, mothers are given antibiotics which cross the placenta and can impact that gut. Babies born by C-section also don't typically receive that early nursing, and breastfeeding is very important for the inoculation of the gut. In fact, there are oxytocin and other hormones involved in nursing cause some of the bacteria in the gut to be released and to enter into the ducts and are placed right into the milk that goes into the baby and inoculates the baby's gut. So it's very powerful that the baby actually begins to inherit by breastfeeding the mother's microbiome. And the developmental environment also impacts the baby's microbiome. And today, with not only the overprescription of antibiotics, but antibiotics in food have a direct impact on the health of the microbiome of children. So the bacteria in our gut, the microbiome, have a variety of effects, and it continues to grow almost month by month as we learn more about the microbiome. But we know today that the microbiome, the bacteria, influence and modulate bone density, promote or lessen the storage of fat. They impact angiogenesis, and this is the growth of blood vessels. And the blood vessels are important for so many reasons. One is obviously wound healing, the healing of injuries, but the other is that cancer, especially the growth of cancer and the metastasis of cancer, are dependent upon the rapid growth of blood vessels. But the microbiome helps to modulate and control this. And there have been studies in poor wound healing that as lactobacillus increases in the microbiome, wound healing can accelerate. We also see that the bacteria are involved in development and training of the immune system through T regulatory cells, that they're involved in the biosynthesis of vitamins like vitamin B12 and vitamin K and amino acids. The bacteria help metabolize therapeutics, they modify the nervous system, break down food substances. They're involved in the resistance to pathogens. And one of the interesting parts of research is that antibiotics have largely been used in animal agriculture, initially for growth of the animals. Now, this is a significant impact. More than 70% of the antibiotics produced today end up in animal agriculture. And what we see is that there's the rapid development of resistance to antibiotics through this widespread use of antimicrobials in animal production. Those genes of resistance, though, are transferred through the food system to our microbiome, and it's one of the sources of the development of antibiotic resistance in humans, and it begins right in the microbiome. And we also see that these bacteria in the microbiome protect against epithelial cell injury. So a host of impacts of this key center of a microbiome. The microbiome is also influenced by our environment. And we're going to talk about this in the next several slides, called the exposome. The microbiome appears to be impacted by where we live, and that can be whether we're living in a more sterile environment or an environment where there's more bacteria. In fact, they find that children that grow up with animals have lower allergy rates and a different microbiome. Diet is one of the key impacts of the microbiome, influencing gut health and also impacting susceptibility to so many diseases like IBS, IBD, and even reflux disease. Antibiotics, as we talked about, metformin impacts the microbiome positively, and they believe that one of the roles of metformin in improving blood sugars may actually be its positive impact on the microbiome. Statins have a negative impact on the microbiome. Proton pump inhibitors have, including NSAIDs, other medications, have a very negative impact on the microbiome. Stress, psychosocial factors, exercise, and even surgery and radiation can shift the microbiome in a negative direction and impact healing. And so we have this dynamic relationship with our microbiome that can change even in the course of one day. We can see a overgrowth of unhealthy or healthy bacteria based upon choices and environmental exposures that we are seeing on a daily basis. And we see that the host effects here on the right-hand side are a number that based upon the types of bacteria, we have the production of short-chain fatty acids, which we'll talk about later, which have a profound impact on our health. The vitamins, signaling, bile acid regulation, fat storage, satiety, as we talked about, and even the gut-brain axis, with a significant body of research showing that the types of bacteria may even influence many of the psychiatric diseases. So again, just to highlight, we have this exposome, our geophysical and social environment that impact the microbiome and actually impact sometimes our food choices. But really, this diet is such an important component. We see that the balanced diet, including reductions in meat, increased fruit and vegetable intake, leads to a more normative microbiome, whereas a high meat processed food diet leads to an aberrant microbiome. And some key highlights of this is that with a healthy diet, we see normalized BMI, increased in substances like NRF2 that affect blood vessel health and vasodilation. See reduction in inflammation through reductions in TNF alpha, NF kappa beta, interferon gamma, decreased phosphate production. But with the unhealthy diet through an aberrant microbiome, we see an upregulation of all of these, including a downregulation of decreased mitochondrial biogenesis, the powerhouses of the cell that regulate energy and oxidative stress in the body. But what also is very interesting is that with an unhealthy diet and a modified microbiome, we see epigenetic dysregulation. And that is the dysregulation of that epigenome, the genes that are above our DNA that influence the regulation of our genes and are involved in many of the lifestyle-related diseases. So there are a number of things, as we've talked about in the exposome, that impact our gut, but so many of them are related to our lifestyle choices. That's why diseases like irritable bowel, IBD, reflux disease, even heart disease, type 2 diabetes, depression, are influenced by our daily choices on how we exercise, how many hours of sleep we're getting per night, whether we're exposing ourselves to antibiotics through overprescriptions or through diet. The westernized diet, the industrialized diet that's high in meat, high in processed foods, has a detrimental effect within 24 hours of the consumption of those foods. And stress dramatically shifts the microbiome because of the effects of cortisol. And what's very interesting, as we are learning more about the microbiome, we're beginning to see that there are some signatures of these diseases that can be identified as the bacteria shift in relationship to our environmental choices. And this is just a slide to show this shift over time that we see, just kind of to highlight the main colors that we see in a relatively normal weight, normal BMI on the left. We see the yellow and the small amount of green, but as we shift to a more obese signature, we see the types of bacteria dramatically change. And there have been some early studies looking at fecal inoculation of the microbiome from healthy, normal weight people to those that are unhealthy, and the development of healthier microbiome and weight loss. And so the types of bacteria dramatically impact even the management of energy and calorie absorption in the gut. And we see that in those people that are susceptible, when they're eating high calorie density, industrialized diet, that it begins to shift to a low diversity microbiome. They begin to have an overgrowth of unhealthy bacteria like Firmicutes and Enterococcus and Klebsiella. And as those bacteria begin to grow, we see the development of not only inflammation, but also obesity. And it's not just the calorie and the energy balance, but it also has a direct impact on insulin resistance. And we see that through the production just above LPS, lipopolysaccharide, from the gut bacteria, that it contributes to the development of non-alcohol fatty liver disease, that it activates macrophages, leading to inflammation in the adipose tissue. We know that inflammation directly feeds back into the development of insulin resistance because it dysregulates insulin signaling at the insulin receptor on the cells. We see that this unhealthy diet through the lack of short chain fatty acids here on the left alters lipogenesis and gluconeogenesis in the liver, leading to alterations in fat storage. And as we're going to talk about a little bit later, the choline, predominantly in meat and even eggs, produces TMA, which becomes TMAO in the liver, which activates macrophages, leading to foam cell development and cholesterol deposition in the arteries of the heart, inflammation and relationship to death, stroke, atherosclerosis, and even chronic kidney disease. And what's been so interesting is that the research has shown that within 24 hours of shifting from plant-based proteins to animal-based proteins, the microbiome begins to change, and we see a change in the types of populations that are in the gut. We see the increase of bifidobacterium and lactobacillus with plant proteins, which increases short-chain fatty acids, which improves the health of the gut barrier, increased Tregs, which is T regulatory cells, and reduces inflammation. And these are really key steps for people that are struggling with IBS and IBD and other gut issues. The shift to plant proteins really helps to reduce the dysbiosis that's associated with these diseases, increases the integrity of the gut barrier and those tight junctions that we'll see in just a minute, and reduces inflammation, which is so critical for patients suffering from so many diseases. But as patients consume animal-based proteins, there's an growth of these unhealthy types of bacteria and a downregulation in the growth of healthy commensal bacteria. And as a result, we see an increase in TMAO, cardiovascular disease, decreased short-chain fatty acid, with the development of all of the irritable bowel diseases and irritable bowel syndrome that's so common today around the world. But it really begins with what we're putting in our mouth, and the sources of the food, including the proteins, have a profound impact within 24 hours on the health of our microbiome. So we see that this inflammatory molecule, trimethylamine, which is oxidized in the liver to become trimethylene oxide, is created by the unhealthy bacteria that are really driven by the foods that we eat, the animal-based or industrialized diet. So the development of this TMAO has a number of significant clinical effects. It's been related to the progression of chronic kidney disease because of its impact through inflammation on the kidney and the vasculature of the kidney. We see through the inflammatory pathways that it impacts type 2 diabetes. We see that it leads to the development of atherosclerosis by activating endothelial cells and macrophages to develop foam cells and lay down cholesterol plaques inside of those arteries. We see it's involved in metabolic syndrome, heart attack and stroke, and a number of other diseases. This research initially started with Stanley Hazen at the Cleveland Clinic and now has become widespread with now the availability of lab work to look at TMAO, which we've done in some of our immersions and seen some very interesting changes, even in a week's time, with a shift to a plant-based diet and the reduction and alterations in TMAO production. We also see that this microbiome impacts type 2 diabetes. And on the left here, we see a comparison of the plant-based diet versus an animal-based diet. And we see a shift again in the types of bacteria, the healthy bacteria that produce short-chain fatty acids like Prevotella, Bacteroides, Bifidobacterium, versus the unhealthy animal-based diet with an upregulation of Firmicutes and Proteobacteria and Clostridium. As we look at the production of short-chain fatty acids, and we'll see the benefit of that in the next couple of slides, we also see that a plant-based diet increases anabolic enzymes, and all of these lead to improved homeostasis of the microbiome with increased gut mobility and motility, decreased insulin resistance, improvement in the leaky gut syndrome. But we see over here on the right side that as we increase the populations of those more pathogenic bacteria in the microbiome, it leads to inflammatory molecules like lipopolysaccharide, peptidoglycans, inflammatory mediators like TNF-alpha and interferon gamma and NF-kappa beta. We see progression of insulin resistance, increased inflammation, and increased leaky gut. And I'll just highlight on the right side, this is a comparison again, kind of visually of the healthy conditions and unhealthy conditions in diabetic gut. But we see the loosening of these tight junctions on the right side in unhealthy gut. And the loosening of these tight junctions is a critical step, not only in, as we see, inflammatory molecules and the development of leaky gut, but this is a critical step also that leads and contributes to IBS and IBD. And so as we begin shifting to a whole food plant-based diet, we can begin to understand some of the benefits of a delicious meal like we're seeing. That not only does this contain more than enough protein and amazing complex carbohydrates and the right amount of fat that our body needs, but it also contains a very important component that's fiber. And from the NHANES data here in the United States, we've found that only 4% of any age group meets the adequate intake, the AI, for fiber. We can see across all age spectrums that most people are not achieving the adequate intake of fiber, which is listed between 25 and 30 grams. Actually, the adequate intake of fiber, when we look more at the microbiome, is probably closer to 70 grams. And even many ancient people groups eat upwards of 100 to 120 grams of fiber on a daily basis. There's also some very interesting relationships between the amount of fiber that people consume and their risk of a number of diseases, including heart disease. And we see almost a linear regression of risk as people increase the amount of fiber in their diet. And we know that as you increase the fiber, it's related to the increase in whole plant foods. And And we know that this is a complex system. And so it's not just the fiber that's reducing the risk, but it's the fiber and the phytochemicals, the minerals, the antioxidants, the vitamins, everything that's contained inside of that plant-based food that reduces risk. But we can see as you get closer and closer to the 70 grams of fiber on a daily basis, a significant risk in heart disease. We also see this that, as people increase their consumptions of fiber, reduces risk of all diseases. And for those that are struggling with IBS and IBD, there's also a significant reduction in the risk and flares associated with that once they get through the challenges of an inflamed gut. There are lots of benefits of fiber, not only just reduce constipation, but a significant reduction in colorectal cancer. Fiber also has a viscosity effect in the gut, which slows gastric emptying, leading to greater satiety. Fiber reduces the absorption of cholesterol, estrogen, and glucose in the gut, which people often don't realize. And in fact, in women, there's a greater balance of estrogen, progesterone when they are consuming higher amounts of fiber. The gut whisks away the extra estrogen, and it's not reabsorbed or utilized. We see a favorable impact on gut peptides and adipokines like leptin and adiponectin that have a direct relationship to BMI and satiety. The fiber binds bile acids and actually increases cholesterol excretion. But importantly, the fiber that we can't digest is actually digested by the bacteria in our gut to produce short-chain fatty acids. And the short-chain fatty acids, butyrate, propionate, and acetate, have a profound impact on our body. So these are the byproducts of the digestion of fiber, the non-soluble fiber that's in our food that actually are released locally and peripherally throughout our body. Locally, the short-chain fatty acids reduce inflammation in the gut, directly impacting the gut diseases and the risk for colorectal cancer. They also serve as energy for the colonocytes to improve the health of the colon. We see that these short-chain fatty acids are involved in the glycemic response. Butyrate normalizes blood sugar for up to 4 hours. They're involved in satiety. They promote weight loss. They enhance mineral absorption. They reduce systemic infection. Inflammation. It's been shown that butyrate actually feeds back to turn off one of the key switches in inflammation, which is NF-kappa beta. And the short-chain fatty acids like butyrate are involved again in T-cell regulatory production. And so it enhances the immune system. So for many reasons, the whole food plant-based diet impacts the health of the gut, reduces local inflammation, reducing gut diseases like IBS and IBD, but also has systemic effect, reducing the risk of all diseases. The whole food plant-based diet by the research shows that it increases the diversity of the microbiome, which is profoundly impactful on human health and aging. It increases the growth of short-chain fatty acid producing bacteria. It's interesting that research shows that a whole food plant-based diet also suppresses the growth of pathogenic bacteria like Salmonella and Clostridium in the gut. The polyphenols, the phytochemicals in the food, like in a beautiful mango, have been shown to increase the short-chain fatty acid producing bacteria, Bifidobacterium and Lactobacillus. The monounsaturated and polyunsaturated fats that are found in plant-based foods positively affect this Bacteroides firmicutes ratio, which is related to a number of diseases, and improve the short-chain fatty acid production. Whereas in animal-based foods, we see that the saturated fats negatively shift the microbiome and produce inflammatory molecules. And the plant-based protein reduces pathogenic bacteria as well. So for a number of reasons, our microbiome is impacted by those delicious foods. And it's one of the reasons that I enjoy a wonderful curry dish. And so we get the pleasure of enjoying this food, but as we eat this food, it's going down and having a profound impact on our gut health, and throughout our bodies. So thank you so much. I think we have a few minutes for questions. And again, if you have questions, please type them in the Q&A bubble, and we'll take a few questions before we hear from Dr. Sant. So Tom?
Great, Scott. Thank you so much. We don't have a lot of time for questions here, so I'm not going to beat around the bush. We'll get right to some of them. So let's start off with a couple of quick ones. Well, somebody asked about fiber. Who needs more fiber, men or women?
It's an excellent question. I know there's a little bit of differential in the research. I simply tell all of my patients that everyone, women, men, and children, need more fiber. And our goal really should be to shoot for at least 70 grams of fiber on a daily basis. And the only way to actually attain that, it's either big glasses of Metamucil, but the optimal way to attain that is a whole food plant-based diet. With a whole food plant-based diet, you can actually reach the 70 and beyond level of fiber that all of us need to have a healthy gut and a healthy life.
Thanks, Scott. How about fresh? Someone asked about fresh fruits and vegetables. Are they high in these beneficial bacteria, or do they contribute to it? Obviously, it sounds like they do, but any specifically fresh fruits and vegetables, are they high in any specific bacteria?
So it's interesting that when we look at, there's some interesting research looking at organic produce and the types of bacteria that are on the leaves of organic produce. And eating produce that you grow or that is grown organically contains bacteria that actually colonize our gut and improve the health of our microbiome. When we eat conventional produce that's been irradiated, has no bacteria. And so we're not getting that kind of daily inoculation with that bacteria. The fiber that's in beans and lentils, the fiber that's in fruits and vegetables also all feed the microbiome. And so in that way, the fiber feeds it. But as we shift towards healthier, regenerative organic agriculture, or even better, the food that you grow in a kind of an organic environment at home, you're also getting healthy bacteria on a regular basis that you're inoculating into your microbiome.
Thank you, Scott. How about food preservatives? Do food preservatives impact gut bacteria?
Food preservatives definitely can, and we're even seeing that some of the artificial sweeteners, including xylitols, including things like processed stevia, can have a negative impact on our gut microbiome. And so it's another reason to shift to a whole food plant-based diet, to try to avoid those kind of consistent small impacts on the microbiome that might be found in processed food.
Thank you, Scott. Here was an interesting question. Does obesity cause an unhealthy microbiome, or does an unhealthy microbiome contribute to obesity?
Yeah, that's a great question. It's a chicken and the egg question. But I think when we look at the exposome and we understand the relationship of environment to our microbiome, it's more the latter. It's more the environment impacting the microbiome. As the microbiome begins to shift, starts to drive hunger signals, which trigger eating and cravings. We also know that an unhealthy microbiome can drive cravings for sugars. Unhealthy microbiome increases the absorption of calories. A healthy microbiome actually modulates the amount of calories that are absorbed. And so it's much more environmental. But what's interesting, even in the environmental, is that the research shows that that people that have friends that are heavy, independent of even the food intake, their microbiomes become similar, very, very similar, through this shared kind of relationship with people and the sharing of our microbiomes. And so there may be kind of a predisposition to that microbiome because it is shared, it is inherited from mom. And so that may predispose people to overeating as well. So there's this really dynamic kind of two-way impact between our environment, our inherited microbiome, and then the lifestyle choices that we're making.
Thank you, Scott. Next, why should methionine, an essential amino acid, be decreased in the diet?
Oh, so methionine, yes. So methionine
I'm
decreased in the
sorry.
diet. Yeah, so it's predominantly in more animal-based foods, and there's a relationship for cancers, even breast cancers, and we see that alteration with even branched chain amino acids, high in methionine, alter the microbiome. And so, and when that microbiome is altered with branched chain fatty acids and methionine, again, it's an increased risk for cancer. And so that's the reason, part of the reason, a short answer, for methionine reduction. It's a very interesting study, and we'll go into more of that maybe another time. But yes, and when we shift to a whole food plant-based diet, there's a natural reduction in methionine to more normal levels.
Thanks, Scott. Next question, can the microbiome of a C-section baby become similar to the microbiome of a baby delivered vaginally? Can this be done over time with a plant-based diet?
Yes, that's a great question. It's interesting, they've looked at that in the research, and they have developed kind of a controversial intervention of doing like vaginal seeding, it's called, where they take vaginal fluid and swab the baby's mouth to try and get that first exposure. That research is still outstanding. We don't know how well that works. Research does show that over the course of time, the microbiomes become more similar. But certainly, as baby begins to eat more whole foods, in that 4 to 6 month range, especially plant foods, those non-soluble fibers will begin to feed the lactobacillus and bifidobacterium and bacteroides, and you'll begin to see a healthier microbiome over time. And so, that's the good news, is that this is a very dynamic process that will shift pretty quickly in the direction of a healthy microbiome, and also avoiding antibiotics as much as possible in childhood is really, really important. Looking for alternatives to, utilizing antibiotics. There are times when it's necessary, but most of the time it's not necessary. And then again, it's animal products that are a great exposure for antibiotics as well. And dairy dramatically negatively impacts the microbiome. So one of the most important things for children is to not be exposed to cow milk.
So, two more quick ones. Will breastfeeding mothers taking antibiotics pass those antibiotics along to the baby, and is that harmful to the child?
Yes, and so that is, antibiotics taken in through the mouth through breastfeeding will impact the health of the microbiome. Antibiotics kill bacteria, and so, the research has shown that when an adult takes a course of antibiotics, that it can negatively shift the microbiome for up to a year. And so, if mom's taking antibiotics and nursing, there is a small exposure of antibiotics for baby, which will impact baby's gut. And so, it's a balance, because we know as clinicians, there are times when antibiotics are really necessary. And we use those when it's necessary, but the tenuous balance is to not overuse them or not prescribe them when it's not absolutely necessary, especially in nursing mothers, because not only affects mom's gut, but it's also impacting baby's gut, which impacts baby's immune system through the regulatory T cells and the short chain fatty acids, which increases baby's risk for other infections.
Thanks, Scott. Last one, quickly. Can physical activity, basically exercise, affect the microbiome? So what is the effect of exercise on the microbiome?
Yeah, and that's also the good news, is that activity positively impacts the microbiome, shifting again toward those bacteria that are producing short chain fatty acids, decreasing the pathogenic bacteria, and kind of normalizing the gut. And so that's, another one of the many benefits of exercise, from new brain cell neurogenesis growth, normalizing blood vessel growth, angiogenesis, and normalizing the gut. So reducing cortisol, I mean, exercise has so many amazing benefits. But one of them is, yes, a positive impact on the microbiome. So.
Okay, great. Thanks so much for the questions, everyone. And thanks for those great, insightful answers, Dr. Stoll. Again, we're tight on time, so I'm just gonna, I'm just gonna send it back over to Sachin, and he'll lead us back through the second half of the webinar. Sachin?
Yeah. Thanks, Tom, and thanks, Scott. That was a really, really interesting session. So, ladies and gentlemen, as I mentioned earlier, that we will talk about simple, effective, and scientifically proven methods to take charge of our health. And we have a real example of someone whose story is so inspirational. Our next speaker, Dr. Sant Chaiyodsilp, is a former cardiac surgeon with over 20 years of experience. After being diagnosed with coronary artery disease, he rejected surgical treatment and conducted his own research in prevention and reversal of chronic disease. And through his efforts, he recovered without a surgery, becoming healthy, and through a theory of total lifestyle modification. He is currently a consultant with Thai Heart Association. Along with Mr. Vivek Dhawan, CEO of Mega Life Sciences, he has established the Wellness We Care Center in Thailand to develop training programs for general public and healthcare providers on self-prevention and reversal of chronic diseases through dietary and lifestyle changes by incorporating plant-based whole food diet along with regular exercises. So, ladies and gentlemen, may I invite Dr. Sant?
Can't see anything. Sorry.
Oh, we can hear you, Dr. Sant.
Can you see me?
Yes, we can.
Okay. It's a pleasure to be here with you again. Let me start my slide to save time. Okay. The topic I will focus today is to answer the question, can we use plant-based nutrition to prevent and reverse neurocognitive disorder? Before starting my evidence review, let me touch a little bit about dementia. The word dementia is now officially changed to neurocognitive disorder, shortened as NCD. So don't be confused with non-communicable diseases, which also shortened as NCD as well. In my talk, NCD means neurocognitive disorder only. Firstly, let's look at detail of what we call brain function. It includes 6 areas: attention, particularly complex attention; memory and learning; language; social interaction; perception and motor, mostly concern movement; judgment and decision, or put it the other way, cognitive function. So when we talk about neurocognitive disorder, we talk about losing any or all of these 6 functions. Now let's take a bit closer look at dementia. It can be subdivided or subtyped into many diseases. The biggest one is Alzheimer's disease, which is 70% of all dementia. This is a disease of unknown origin. Rank number 2 is vascular dementia, which is 20% of all dementia. The rest are not important. I will not go into any detail. They are Lewy body dementia, Parkinson's disease, frontotemporal dementia, traumatic brain injury, HIV infection, substance and medication usage. In terms of severity level of the neurocognitive disorder, it can be classified into two levels of severity. One is minor neurocognitive disorder, previously called mild cognitive impairment or MCI. It is defined by loss of some memory, but still able to do daily living. Level 2 is major neurocognitive disorder, or previously called dementia. It is defined by inability to perform daily living. Let me touch a little bit on daily living, which is used to define the severity of neurocognitive disorder. On the left hand is ADL, daily living, which means 5 essential activities which needed to live independently. One must be able to eat, to go to toilet, to take a bath or brush teeth, to get dressed or to walk. Usually, patients with major form of neurocognitive disorder will lose at least one of these 5 ADL functions. On the right hand is IADL, or instrumental daily living, which means 7 important activities to maintain quality of life. One must independently be able to make a phone call, to do the self-transportation, to do cooking, to do shopping, to do housekeeping, to manage medication, and to manage financial stuff like able to manage credit cards, bank accounts, and paying bill, etc. Usually patients with minor form of neurocognitive disorder will lose one or more of these 7 functions of IADL. Now let's take a quick look at 3 commonly used tests to diagnose the minor form of neurocognitive disorder. Test 1, MMSE, that stands for Mini Mental Status Examination. It is a test on memory, speech, and writing. It takes about 20 minutes to do. Test 2, called Mini Clock test, basically is drawing a clock to tell time with the clock's short arm and long arm. Test 3 is NTB score, short for neuropsychological test battery. This is multiple small tests. Each test aims for each particular function of the brain. Different patient gets a different battery test. Okay, now come back to our main question. Can we use plant-based nutrition to prevent and reverse neurocognitive disorder? Let me bring you back to 1970 in Finland, a province called North Karelia. There, they did a common community-based program aimed at reducing ischemic heart disease mortality. Their slogan in that time was "From butter to berry." That was an ambitious program led by a young doctor called Dr. Pekka Puchka. In doing such program, they included all segments of the community, such as health centers, companies, workplaces, factories, supermarkets, school, women groups, television, and even changing law and regulations when needed. They achieved remarkable results. Within 30 years, they brought down cardiovascular mortality down by 75%, reduced butter spreading usage from 90% to 7%, and increased fruit consumption from 44 pounds per person per year to 130 pounds. The success of the North Karelia project provided data enable us to compare the relation of cardiovascular risk factors and incidence of Alzheimer's disease. This study is called CADE study. Prospectively follow and compare 4 groups of patients with different cardiovascular risk factors. They follow them for 25 years. The results of which showed that there was a strong relation between cardiovascular risk factors and Alzheimer's disease, even stronger than ApoE gene. This result led to another important study, the FIGURE study, or better known as the FIGURES. This was a big randomized control trial, recruited 1,260 elderly with mild cognitive impairment, divided them into 2 groups, intervention group and control group. In the intervention group, they did 4 things. Number 1, they changed food from ordinary food to the so-called healthy Nordic diet, which is pretty much similar to Mediterranean diet, consists mainly of fruits, vegetables, fish, and rapeseed oil. For those who are not familiar with rapeseed oil, it is the same plant as canola oil. Intervention number 2, they do exercise. Number 3, they do brain challenge activity. There are many types of activity, 1 activity for 1 patient. Intervention number 4, they manage cardiovascular risk factors, if there is any. They did this study for 2 years. The end result was measured by the NTB score. The result showed that the intervention group ended up with improvement of mild cognitive impairment, while the control group got worse in cognitive impairment. This is the first and the largest randomized controlled trial which showed that multi-lifestyle intervention, including changing food, can prevent and reverse minor form of neurocognitive disorder. And the FIGURE study gave rise to the worldwide FIGURES, which designed to replicate FIGURES. Altogether, there are 5 big studies ongoing at this moment. The Pointer study in USA enrolled 2,500 subjects. The PREDIMOS study in China and UK enrolled 2,400 subjects. The HITIS study in EU enrolled 2,700 subjects. And here in Thailand, the impact of lifestyle modification on prevention of dementia enrolled 3,600 subjects. Another big one is in Australia, the MYB trial enrolled 8,500 subjects. All these 5 trials aim at replication the result of the FIGURES. All the results should come out in the next few years. Anyway, at least for the time being, the result of the FIGURES is enough to tell us how to prevent and reverse minor form of neurocognitive disorder. Let me emphasize here again, changing food, do exercise, challenging brain, and manage cardiovascular risk factors. What about Alzheimer's disease in particular? So far, as what we get from epidemiologic studies, there are 7 suggestive risk factors: hypertension, obesity, diabetes, physical inactivity, smoking, depression, low education. Now let's take a look at food and Alzheimer's disease. We know from this study that adhering to Mediterranean diet associates with reduction in cognitive impairment and Alzheimer's disease, as well as reducing the transition from minor form to major form of Alzheimer's disease. What about the relation between vegetables and the brain? This study showed that for those whose age are 65 up, the risk of cognitive decline was 38% lower in those who eat high amount of vegetable, comparing with those who eat low amount of vegetable. This study compared two types of diet on changing of the volume of the hippocampus, which is part of the brain related to memory and learning, between one type of diet, a so-called prudent diet, which consists of fresh vegetable, salad, fruit, and fish, and another group of diet called unhealthy Western diet, which consists of roast meat, sausages, hamburgers, steaks, chips, crisps, soft drinks. After 4 years follow-up, the result showed that consumption of prudent diet was associated with 45.7 millimeter larger left hippocampus, bigger brain. While the other group who consume unhealthy Western diet was associated with 52.6 millimeter smaller left hippocampus. What about the bean and the brain? This study compared consumption of beans or legumes and brain growth. It showed that higher intake of legumes was associated with larger parietal and occipital-cortical thickness of the brain. Whole grains also affect the brain. One study showed that higher intake of whole grains was associated with larger temporal pole and superior temporal cortical thickness of the brain. Another study showed that lower intake of whole grains was associated with higher inflammatory markers. In this case, they use interleukin-6 and accelerated cognitive decline. Now let's take a look at how type of fat in our food affect our brain. The first study showed that cognitive function was negatively associated with saturated fat, omega-6 fat, and homocysteine, but positively associated with intake of omega-3 fatty acid. But later on, there was another randomized controlled trial called MAP trial in France, which is better in terms of research design. The MAP trial showed that there was no relation between omega-6 fatty acid and cognitive function. So the effect of omega-3 fatty acid. So the effect of omega-3 fatty acid on brain is not conclusive yet at this stage. But definitely, all research shows similar result that there is negative relation between saturated fat and cognitive function. This research show that in those aged 65 years up, consuming saturated fat more than double the risk of developing Alzheimer's disease. Please be reminded that we get most of saturated fat from animal products, palm oil and coconut oil. From the epidemiologic evidence point of view, most of them also showed negative relation between animal products and Alzheimer's disease. In this study, it showed that in 10 countries, starting before Alzheimer's disease prevalence, dietary supply of meat and animal products, including eggs, for 5 years had strongly correlate with the increasing incidence of Alzheimer's disease. While countries with low consumption of meat had the lowest rate of Alzheimer's disease. Now, this study take a closer look into Mediterranean diet. This study showed that closer adherence to Mediterranean diet was associated with less decline, in improved in MMSE test. But when look closely into detail of each subgroup, it turned out that only vegetable consumption was inversely associated with cognitive decline, not meat consumption. Now this is the MIND study, a very famous one. In this study, they divide food into 2 groups. On the right column is the brain unhealthy 5 items: red meat, butter and margarine, cheese, pastry and sweets, fried and fast food. On the right column is the brain healthy 10 items: green leafy vegetable, other vegetable, nuts, berries, beans, whole grain, seafood, poultry, olive oil, and wine. And from this list, these two type of food, they develop what they call the MIND diet score and do the research on cognitive decline. They found that the more people eat higher score food, the younger their brain will be. Those who eat the top 1/3 of the score have 7 years younger brain than those who eat the bottom third of the score. Since amyloid deposition in brain tissue is a hallmark of Alzheimer's disease, so it is interesting, where does amyloid come from? This research showed that bacteria populating in our gut, or the microbiome, produce amyloids, lipopolysaccharides, and other immunogenic compounds that contribute to neuroinflammation and amyloid deposition in the brain and the subsequent Alzheimer's disease. So gut microbiome relate to Alzheimer's disease. And of course, the type of food we eat directly dictate the type of bacteria in our gut. This highlights the importance of food as the contributing factor to amyloid deposition in Alzheimer's disease. You will see from all the evidence I have presented that plant-based nutrition can prevent and reverse minor form of neurocognitive disorder. But we should not rely on only food. This study is called the Duke study. They're sampling 160 cognitive impairment patients, divide them into 4 groups. Group 1, eat healthy diet. In this case, they use DASH diet. Group 2, do exercise. Group 3, do both. Group 4, do nothing. And then follow them for 6 months. The results showed that the best reversal of cognitive impairment occurred in the group who did both, change food and exercise. So combination of lifestyle factors are better than focusing on only one factor. Also, we cannot ignore meditation. This is one example of many studies which showed positive correlation between meditation and cognitive function. In this research, meditation slowed the rate of hippocampal volume atrophy in those patients with mild cognitive impairment when compared with control group. I will conclude with this slide. Plant-based nutrition evidently helps prevent and improve cognitive decline. But diet should be used in tandem with other lifestyle components to make a kind of total lifestyle modification, which include plant-based nutrition, exercise, cardiovascular risk management, brain challenging, and meditation. Okay, thank you for your attention, and I will hand over the screen to Kun Sachin, please.
Thank you, Dr. San. That was a very interesting presentation, very insightful. So now there is a question for the audience. So we want the audience to help us answer two questions. So we'll just publish a poll. And for our next 20 seconds, there are two questions, and you can choose what do you want to answer. So here is the poll, and then we will jump to question and answer sessions with Dr. San. So 20 seconds, Dr. San, and then we come back to you.
Okay.
All right. So
All right.
here is the poll for you. Can we have the poll, please?
It is published.
All right, great. All right. Do you see the poll on your screen, audience? Please vote, please. All right, and while you continue to vote, a lot of you have been asking questions whether you'll be getting a recording of this webinar. So the answer is yes. Not only just this webinar, but the recording of earlier webinars also would be available to you. By tomorrow, this time, please check your mail. You will get a link to a web page where on your registered email ID, and on that web page, you will get recordings of today's webinar as well as all the earlier webinars which we have conducted. And not only that, you'll also find there a guide on plant-based whole food diet and its health benefits. So you can download that guide as well. So thank you for the participation in poll. And here's some quick questions, your questions to Dr. Sant, which I'll be asking on your behalf. So Dr. Sant, what are your recommendations on the servings of fruits and vegetables one should eat every day?
If you base on the USDA latest guideline, 5 of fruits and vegetable in combination servings, 5 servings per day. But if you want to reduce your blood pressure, the DASH diet, they suggest 5 servings of fruits plus 5 servings of vegetable. So you have 2 choices from 5 to 10, whichever you want.
Thank you. I'm going to ask 2 very simple common questions, but people have been asking this, is that would you recommend preserving of fruits and vegetables through pickling? Should it be done or not?
We have very limited data about the pickling, the preservation of plant. So far as we know, it contains some vitamin B12 from the bacteria, but the ill effect of the preserved plant in terms of pickling. I cannot think of any study to show that. So I cannot answer this question. I cannot think of any evidence to blame the prickle, the preserved plant.
Okay, so not enough studies done on this.
Right.
Right. And another very common day-to-day question is bread we get in the market, is that okay as a plant-based diet?
There are 2 points. Point number 1 is the percentage of the whole wheat, percentage of the unpolished flour used in there. So this point we've got to rely on the label. Usually they put only 20%. That means another 80 is polished flour. And point number 2 is the amount of salt in that bread. Usually bread is one main source of salt. So I would recommend check the label, choose the highest percentage of non-polished flour and lowest amount of salt.
Great. So that brings us to a very interesting insight, as you just mentioned, check the labels, because many a times, although it may appear as a plant-based food, but they may be highly processed, and there goes all the good effects out. Right? Highly plant-based, highly processed foods are not recommended. Am I right?
Right.
And now 2 questions which we get every time when we talk of plant-based whole food, and Dr. Sant, you can guess it. Which oil is healthy?
If you got a cardiovascular disease or diabetes, no oil is the best. No oil at all is the best. I mean the additional oil, not natural oil in seeds. But for general people who do not have diabetes or cardiovascular disease, I think the best oil should be mono unsaturated oil, like olive oil or rapeseed oil. The rapeseed oil, another name is canola oil. And the reason I recommend the mono unsaturated fat is because it can resist heat at some level, and it associates with lower incidence of cardiovascular disease. Right.
Thank you. So since we have already run out of the time and we have exceeded our time, but due to the very interesting discussions today. So this is the last question for today, which I'll put to both our panelists. So here is a very common question, first to Dr. Sant and then to Dr. Scott. So the question is, where do I get my proteins from if I'm on plant-based diet?
Let me emphasize here again, we are protein mania. I mean, because actually our nature, we require not that much protein. At the age of the first year of life, we need most protein. The natural source of protein is mother's milk, breast milk, that contain only 1%, 1% protein. So we do not require that much protein. The second point is that the real source of protein is plant. Even the animal like cow or pig, they cannot produce what we call essential amino acid by themselves, because they are like us, they are mammals. So they got to get essential amino acid from plant. So and some kind of plant contain all essential amino acid in there, like in soybean, or in quinoa, for instance. And practically when we eat a large variety of plants, and we get all essential amino acid. So I have never seen in my practice, nearly 50 years, I have never seen the protein deficiency in patient, never. Okay.
Dr. Scott.
I think that was a very complete answer, Dr. Sant. I would only add that I ask my patients, how do you want your protein packaged? So it's evident from the research and any nutritional calculator that if you're getting sufficient calories from plants, that you're going to get more than enough protein. You will never be protein deficient. So the real question is, how do you want your protein packaged? Do you want it packaged from animals that come with saturated fat and inflammatory molecules and endotoxins that cause oxidative stress? Or do you want your protein packaged from plants that contain antioxidants and phytochemicals and minerals and vitamins that optimize every part of your health from the DNA on up? So Dr. Sant, you did an excellent job with that. I don't have anything else to add. And Sachin, I'll turn it back to you. And I just want to thank all the panel, thank the team for an amazing job, and all of you for joining us today.
Thank you. I mean, we have really exceeded our time by a good 20 minutes over the earlier plan of 60 minutes, and questions are still coming, but there is a limitation. So over to Tom to say a few words before we close. Tom?
Yep, I'm here as well. Thanks so much, Sachin. Appreciate it. Wow, what great information presentations we just had. I know I speak for Dr. Stoll, Dr. Sachin when I say it's a pleasure to share this information with everyone. We hope, like last time, we got you continue to rethink the role of nutrition in human health. We also hope you'll take this information, this life-saving information, back to your hospitals, clinics, patients, clients, family, and friends. If you do this, you'll see firsthand just how powerful of an intervention plant-based nutrition can be in preventing and treating chronic conditions, all sorts of chronic conditions, specifically the two we discussed today in digestive health and cognitive health. On behalf of the project, the Plantrician Project, our board of directors, I just want to say again how thrilled we are to be working with our friends in Thailand at Wellness We Care and Mega Life Sciences. We're really excited for the great things to come, and fingers crossed, hopefully a live event here sometime in the near future, maybe the end of 2021, but we're still working on that. You know, as helpful as these online events are, nothing can really replace those in-person learning experiences, as well as the benefits of building, you know, those in-person relationships and friendships around, you know, a common interest of plant-based nutrition. So we hope you'll consider joining us in person once the situation normalizes and we're able to conduct a live event safely. So details to follow on that as again things change. So on behalf of our speakers, the Plantrician Project, Mega Life, Wellness We Care, I want to thank you for joining us. Again, you can reach the Plantrician Project on the web, Mega Life Sciences on the web, as well as Wellness We Care on the web. So thanks again. That's it for today. Once again, thanks for joining us. We hope to one day meet everyone in person, and we wish everyone health, happiness, and safety moving forward. Stay well and stay safe.